This video will cover statistical literacy, and before we get started on the material, I just wanted to point out in our My Courses course, Cycle 1A module, What are the chances? In here, there are statistical literacy handouts, one on probability, one on the mean, median, mode, etc., and then samples and statistical literacy. There are some activities here, and there are also some videos. So you don't have these materials in my math lab, but you have them here in my courses. So let's go ahead and take a look at some problems, and we'll do some definitions first. So random phenomenon is when we know what outcomes will occur, but we don't know which particular outcome will happen. And a trial is each time we observe a random phenomenon. So think about rolling a die. We know what can happen. We can get a 1 through 6. Each time we roll it is a trial. And each time we roll the die, we write down what we get, and that's called the outcome. The collection of all the possible outcomes is called the sample space, and we'll denote that with a capital letter S. We group outcomes into events. The fundamental counting principle is a way to help us determine the total number of outcomes in a sample space. So the first experiment has N1 outcomes, and the second one has N2 distinct outcomes. Then the possible outcomes for experiment 1 followed by experiment 2 is N1 times N2. So for example, if the first experiment had 3 outcomes, and the second had 4, and we conducted experiment 1 followed by experiment 2, there would be 3 times 4, or 12 outcomes in the sample space. Tree diagrams are a helpful way to show the sample space. Here's a tree diagram that shows the sample space for flipping a coin, 2 outcomes, followed by rolling a die, 6 outcomes. So 2 times 6 is 12, and here are the 12 outcomes. Let's try some problems. Your garage door opener requires a 3-digit number code using the numbers 0 through 9 to open the door. Determine the number of codes that are possible if you cannot repeat the numbers. So for the first number in the code, we have 10 possibilities. We can't repeat, so for the next one we have 9, and for the third one we have 8. So the total number of codes possible are 720. A shoe store carried 1 brand of shoe in 4 styles, 3 sizes, and 8 colors. How many different types of the shoes were available for this one brand? So again, we're going to use the fundamental counting principle, and we're going to take the number of styles, 4, times the number of sizes, 3, times the number of colors, and we come up with 96 different types of shoes. More definitions. Statistics is a way of reasoning along with the collection of tools and methods that help us to understand the world around us. Statistics are also the calculations that we make from the data. For instance, earlier in this unit, in this cycle, we learned about the mean and the standard deviation and the range. The population is the whole group we're interested in knowing about. A census collects information about every member of the population, while a sample is a subset of the population. When we take a sample, we need it to be representative of the population so we can use the sample to make some valid conclusions or inferences about the population. Each sample that is randomly selected will contain different individuals or cases, and the statistics calculated will vary from sample to sample, and this is called sampling variation or sampling error. It doesn't mean it's a mistake, it simply means from sample to sample, the statistician expects there will be variation. We won't get the exact same calculation for the mean from different samples from the same population. A parameter is a numerical characteristic of a population. Parameters are generally characterized by using Greek letters. For instance, the population mean, we use the Greek letter mu, and the population standard deviation, we use the Greek letter sigma. A statistic is a numerical characteristic of a sample, and we use the Latin letters. We use x bar, y bar. For the mean, we use s for the standard deviation. The population of interest is the larger group from which we obtain the sample. One way to help you remember this, population parameter, P goes with P, and sample statistic, S goes with S. Okay, variables. Variables are the data that we collect from the cases. The data are called variables. We have quantitative variables. These are numerical, and these have units associated with them. Examples are things like height, weight, and age. Categorical variables generally name variables, recording them into one of several categories, groups, or levels. Things like gender, political affiliation, religious affiliation, eye color, hair color. And then we can also have identifier variables, which are variables that identify the individual cases, and these are only recorded to allow us to go back to the original case or unit in case we need to collect more information. Some examples of those are student ID, social security number. So we mentioned before ways to collect data. We can do a census where we collect data from every member of the population. We can do a survey where we collect data from a sample. We can do an observational study where we follow large groups of individuals generally over time. We can do a prospective study where we identify the individuals and then we track them forward. We can also do a retrospective study where we identify the individuals and then we go back through their records to gather the information. And we can also do an experiment where we have random assignment of subjects or items to 2 or more treatment groups. The methods by which we can take samples. We can do a simple random sample. It's drawn in such a way that every sample is equally likely to be selected. Stratified sampling is where the population is divided into homogeneous groups called strata, and then random samples are taken from each stratum. For instance, if we divided our population by political affiliation, Republicans, Democrats, Independents, etc., and then we take a random sample from each of those groups. Each of those groups is homogeneous. Cluster sampling, the population is divided into representative clusters where each cluster is heterogeneous and representative of the whole population. Then one or more clusters is or are randomly selected and every member of the cluster is sampled. This is sometimes called geographic sampling. Systematic sampling, a random starting point is selected and then every nth case or individual is selected to obtain the needed sample. In convenience sampling, this is not going to give us a representative sample. We include individuals who are easy to get. They're generally not representative of the population. So let's try a couple problems. A soft drink manufacturer wants to be sure that the bottle caps on the soda are sealed and don't come off easily. Inspectors sample every 200th bottle off the production line and find that caps on 3% of 50 bottles fail the seal test. What is the population of interest? So the population of interest is the larger group that we're taking the sample from, and that would be all the bottles that are manufactured probably at this particular facility. What is the sampling method? The sampling method, here's my key right here. It's systematic, every 200th bottle. The 50 bottles is what? That's the sample that we took. And the 3% here was calculated off those 50 bottles, so that would be a statistic. Let's try another scenario. Some people believe, who race greyhounds, believe that giving the dogs large doses of vitamin C will make the dogs run faster. Investigators at the University of Florida tried 3 different diets in random order on each of 5 racing greyhounds. They were surprised to find that when the dogs ate high amounts of vitamin C, they actually ran more slowly. Is this an experiment or an observational study? Okay, so they gave the diets in random order, so there's our clue there that that's an experiment. What's the parameter of interest? And the parameter of interest is the ability of the greyhounds to run, their speeds. What were the treatments? There were 3 different diets. They must have had different levels of vitamin C. Could these results be applied to all breeds of dog? No, because we only studied greyhounds. We have to be careful not to try to make an inference to a different population. We only used greyhounds. If we wanted to make an inference to beagles, we would have to run an experiment with beagles. In a test of roughly 200 men and women, those with moderately high blood pressure did worse on tests of memory and reaction time than those with normal blood pressure. Is this an experiment or an observational study? Now notice here we're not assigning the men and the women to treatment groups. We're putting them in groups based on a characteristic they already have, which is their blood pressure. This is an observational study. What is the parameter of interest? And we're looking at those tests of memory and reaction time. The 200 men and women represents what? It represents the sample. And how were they selected? And it does not tell us in this particular situation. It didn't tell us how they selected those 200 men and women. In 2006, Consumer Reports published an article evaluating refrigerators. It listed 41 models, giving the brand, cost, size, type, estimated annual energy cost, and an overall rating. For each variable, we want to identify the type, and if it's quantitative, what are the units? So we'll start with the model. So there's 41 models. So model is going to be an identifier variable. And the brand is going to be categorical because probably when we think of brand, we may have more than one model from the same manufacturer. The cost is going to be a quantitative variable in dollars. And the size is going to be quantitative, and the size is given in cubic feet. The type, top freezer, bottom freezer, etc., is going to be categorical. Annual energy cost is going to be quantitative in dollars. Now watch for the overall rating, because this could have been quantitative, but if you notice here, they gave us the kind of ratings that were given, poor, good, etc. So that's going to be categorical. So sometimes a variable you think could be one type of variable may actually be a different type, depending on how the information was collected and recorded. And finally, let's end up with some identifying sampling methods. Every 20th soup can coming off an assembly line is checked for defects. That would be systematic sampling. A $50 gift certificate is given away at the annual bankers convention. Tickets are placed in a bin and the tickets are mixed up. Then the winning ticket is selected by a blindfolded person. This would be a simple random sample. Every ticket is equally likely to win. Children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected. All the children from each of those selected schools is included. This would be cluster sampling. And again, this is geographic. That's your clue. Also, we took the schools are representative of all the schools, and we take a random sample of the schools. The first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. This would be convenience sampling. And finally, viewers of USA Today are classified according to age. Random samples from each age group are selected. There's the strata, the age groups, and so this is stratified sampling.